Okay, well, probably the lion's share of you are here now. Welcome to what hopefully is not Philosophy 12, but is EME 303. My name's Derek Ellsworth, and we'll be taking this journey for the rest of this semester. I guess if you're on schedule, it should be your the first semester of your junior year, typically for this class, for majors within Energy and Mineral Engineering, the Department of, so petroleum, mining, environmental systems, energy engineers, and some energy business and finance majors. And it's fluid mechanics. And I was trying to borrow someone's charger from my iPhone, but you have an old iPhone, the button on the bottom gets, it doesn't work anymore. You have to reboost it by just clicking with the base. But fluid mechanics, of course, is all around us. And we try and link this class maybe to what's going on today. So just as I was walking in today, you walk up the mall towards the library. If you notice, and also on the way out of the door at this side, you see these ripples of erosion. And so these ripples have some kind of frequency. It's caused by rain. Rain runs off, and it causes very interesting pattern, almost like ripples in the sand, but at a very distinct separation. So you could ask yourself questions. If it rained heavier, if the slope was steeper, would these little erosion features be closer together or further apart? So there's all kinds of manifestations, if you like, of fluid mechanics around us. I tried to pull up also, and I'm not sure, how does this stuff look on the board, by the way? Can you make that out? It's probably too bright for starters. Let me... I'm not leaving you, don't worry. You're not that lucky. Good? Better? Blurred? That's okay, most of you won't be here next period anyway, so don't worry about it. So, what's going on in the news today? This weekend has been downgraded, but there's this bubbling volcano in Iceland, not... I can't pronounce the name of the one from 4 years ago in 2010 which erupted, which disturbed all the air traffic across the Great Circle that goes from the east coast of the U.S. to Europe because of fluid mechanics. Fluid mechanics, heating in the Earth's interior, makes magma buoyant. Buoyant material rises in the crust. It breaks out of the surface as pressures get too high. Hits the surface. It has gas dissolved in it. The gas comes out, it fragments the lava as it comes out, gets pushed into the air as an ash cloud. Planes which rely on fluid mechanics can't fly through it, and if they do fly through it, they get their engines sandblasted, basically, and it's not a good thing. And so it was about to happen now. It's been kind of downgraded, but that is absolutely every single aspect of that problem, from 20 kilometers below the Earth's crust to 10 kilometers above the Earth's surface, is a fluid mechanics problem in every sense of the word. And maybe we'll use that as an example to be able to talk about the syllabus that we have in there. Before your time, if you're in this class and you're kind of on schedule, you're probably 20. So I guess you're born in 1994. So 1989 was before your time. But this is not what you want to happen when you're flying around in a plane, or I guess you would fly around in a plane unless you can grow wings. And this is flight, whatever it was, KLM 867, flying to Anchorage, Alaska to refuel, from Amsterdam to Narita in Tokyo, I think. And Redoubt is a volcano in the Aleutian chain on the west coast of the US that erupted, and they happened to fly through an ash cloud. And all of a sudden, the cabin starts filling up with ash, all 4 engines go out. Silence. Not a nice feeling, I guess. And so there's the transcript there, which you can read for yourself from this. They ultimately got them going again. They dropped out of the cloud and managed to get some clear air and start them up again. And so that's why this is a rare for all 4 engines to go out in a plane. I think there's never been an unrelated more than 1 engine flare out at once, which wasn't due to something that, you know, if you had 2 engines, it would happen to all 2. If you had 8 engines, it happened to all 8. But that's why most of the planes now in service have 2 engines. If you fly to to Europe to Asia from the US for that matter, most of them are 777s or three. What are the Airbuses? Three, not 387s. The same. Well, the 303s. Or it's not a 303. It's the 333. Whatever. The equivalent of the 777s. 300 passengers, 2 engines. Much cheaper to maintain 2 engines than it is to 4. And there's no real safety concerns related to it, because if one goes out, you can always glide 200 kilometers on one engine to get to where you need to go. So anyway, fluid mechanics is all around us. So that's the point I wanted to make to start off. So it can be exciting, the things we're talking about. All of the course materials for this class are on Angel, and also on a couple of other components. So let me take a guide through here. Let's see how fast our connection is. The syllabus is on there, which we'll go through piecemeal in a second. The other course notes, so everything you need, I think, is in this copy here. So you can download this. I'll download it and maybe let it do its own thing see how fast it is. Oh, it's pretty fast. It's a big file. It's 50 megs. Perhaps don't do it now because you might kill my connection. But all the material that you'll need for this class exists on this on the Angel website, which I'm sure you're very familiar in dealing with. So I'll save that onto my desktop. What I want to do today is to go through the syllabus. The syllabus is here. The document you have in your hands, and this guy's going to grab here, thank you, is the syllabus. It's for young eyes. It's not meant for me. I can't read that syllabus, but your young eyes should be able to take that up. But it's kind of a legal document in some respects between you and I, and it kind of outlines what exactly we're going to do. So you have a hard copy. It'll change in some minor way, I think, as we go through this class, but not in a major way. So it's 8 o'clock in the morning. You're here. Hope you're here on Wednesday as well, but we'll see how things work out. I sent an email around regarding the textbook. There is a textbook. I didn't bring one today, but it comes in 2 varieties. There's the $200 glossy one with a hardback, which exists in the bookstores, which is has, I think, 13 chapters in it. And then there's a $100 loose leaf black and white one, which is missing the last 2 chapters on compressible flow and turbo machinery, which we don't deal with really in this class. And so either one is fine. One obviously is cheaper than the other. I'm always bemused by the fact that students sometimes sell their books when they get through a class. I think this is, if you're an engineer or a scientist, then the fluid mechanics is a pretty fundamental discipline in all the things that you'll do in your life, or an economist for that matter. Perhaps less so for economists, but it's a fundamental part of your future life, and so I would encourage you not to sell it, but that's not my my call. So either one of these, either the full version or the truncated version, each are fine. One's a loose, is something Open Chevron LL, I think, on the Penn State book site, bookstore site. But it's just as good as the other 2. The only thing you need it for is that the assignment questions, which you'll do every week, are in there. And so if you can borrow that from someone, then you can avoid the outlay of the textbook. But as I say, I think there's a lot of information on the textbook that's useful, backup and background information. So your call, but that's, I've made my case. Don't buy both of them, buy one of them, obviously. My name is Derek Ellsworth. I presume to go on first name terms. I presume to call you by your first names. You're more than welcome, and I encourage you to call me by mine. I know many of you have grown up in the U.S. high school system where it's always Mr. this or Dr. this, and so to me it doesn't matter. I think you can choose to call me other things as well if you so wish as well, but you can at least call me by my first name if you so wish. There are 2 TAs from the class. One is Nick Ward, who's over here, and the other one is Farnood Bin Sidari, who's over there. So they'll set up office hours, probably something like 6 hours a week. Typically it's been on the afternoons of Monday, Tuesday, Wednesday, and Thursday. Assignments are due each Thursday, so that's the reason for that timing. And they'll set them up typically in the study room in Hosser Building, the one on the ground floor, with King Arthur's round table on it to sit around and talk about these things. I don't know, it's up to each of them whether they want to set up kind of online office hours and those kinds of things. I don't think we've done that in the past, but I think that'd be kind of a cool and interesting thing to do. People do things electronically and remotely these days, and this class will be kind of related to that a little bit. So you have their emails. I think they won't set up times yet, still to be determined, because they, like you, as graduate students, have classes to take and schedules to make, and so they don't necessarily know their class schedules yet, and so obviously their class hours won't overprint their office hours. So anyway, so use the people available, me included, I guess, to the full, to be able to get the outcome from this class that you want, that you need. I think in most of the disciplines in EME, you need to get a C or better in the class. I think mining engineering you don't, but I can't remember that. You'd know your own programs better than I. And so clearly if you want to get a certain score, you need to engage to be able to get that result that you want. We try and make it as straightforward. It's a challenging class. I mean, it's not a gut in the vernacular, I would say. It's a challenging class, but I think it's certainly a surmountable class, and it's a useful class because it really is a fundamental underpinning. And I know that when you go into an undergraduate degree, the first 2 years, math this, chemistry this, physics this, why am I doing this? And so certainly in your last 2 years, your final 2 years, your junior and senior year, some of the classes seem to make a bit more sense because they're applied to the disciplines that you're excited about being involved in. So hopefully this is also an entree into that. So the online resources are, I was very pleased with myself yesterday. I put together a class resource page, and this is this here. I don't know. I guess the links don't work there, but I guess I can find it if I go to my home page. Oh, what a nice looking guy. So the other page I made was this, and so you can find it from my home page, or you can also find it from Angel. And so what you might have seen me doing at the beginning of class was one, logging not very easily onto Adobe Connect. So this is broadcast. And so if you choose to, I can't imagine this is going to be the case, but if you choose not to be here at any time, you can always see the classes that we have live by logging into this class broadcast. And you'll be able to pick them up. The second thing I did was that I record a screen capture on this computer. And so everything we talk about is being recorded and being sent to the NSA, and they will send it back to us, and then we'll post it on YouTube. Okay? So everything that we do on the screen, not your interactions, my voice as well, is recorded, and then we upload it onto YouTube, and you might have seen it. So what I'm going to do is that this resource page should have everything on it that you need. It has the syllabus we've downloaded, has the course notes that we've also started to download, the course stats. Okay? You go to ratemyprofessor.com and you can see, oh, Ellsworth, he's an asshole. We don't do anything with him. Well, actually, this class gets pretty good. There are 5 reviews on there, for God's sake. And 1 is mildly complimentary and 4 are not so complimentary. One of them alludes to the fact that easy class, everyone gets an A. Not so. And so, the course statistics are on there. So the grades you can see at the bottom, D, Fs are roughly 20%. And so keep that in mind. That's not atypical for this last year's class. And so you need to get to where you want to be in the class. And so my call to you is to engage and to not let that engagement falter as we go through the semester and you get all these other pressures on you to do things. The weekly workload in this class is not high. Do not make the mistake of thinking that the weekly assignments, if you find them trivially easy or can do them in some other way by playing the system, that will get you through the class. The main scores are on the exams, as we'll talk about. So do engage. So you'll see what the distribution is. More A's, well, more B's than anything else, and C's, so you can see what that is. And The SRTs, for whatever, are okay. They're fine. They're actually pretty good, the SRTs. Contrary to what online stuff would suggest from the sparse data there. Okay, so you can get all the materials on that resource page. You can get it through my web page, or you can also get it through Angel, a link to it. And so what I plan to do on that resource page, by the way, is to upload the materials, which will just be a link to the YouTube channel from that day, and to take the lecture that we had recorded from last year, and that's the archive that moves one back. And so if you want to listen to me all night long to put yourself to sleep, you're welcome to do that from previous years. And so, I mean, they will repeat themselves. It's not going to be brand fresh material, but I think some of the examples that we might choose will be different. And in some cases, so if you go to this archive right now, the archive is last year's introduction. So
all the geophysical circulation.
So you can get that. So I think that's kind of useful. And also this is my YouTube channel. So subscribe. That's the other thing you can do. So when I get back to my office, I'll process the material, I'll upload it to YouTube, and it'll be in this format on YouTube, so that if you subscribe to it, I guess you'd get a notification that something's going up. And I guess I've never done this. I don't block comments, but I guess an interesting thing to do is if people do look at these, and typically I can look at the statistics of the YouTube usage, and typically the usage goes up way before the exam. It's very quiet early on, and then close to the exam, midterms, it goes up. Fine. But I suppose you could comment them on and have your own chat things on the bottom. If people don't understand something, you could ask some questions. I'm not sure that I will answer it. TAs may or may not do. I'm not sure that they would look at it. But other colleagues of yours who know the answers to those questions might be interested in doing that. And also midterm resources are on there. What else? The prereqs are Math 250 or 251 and Physics 212. I don't enforce those. I think some people in our department try to. It's against my philosophy. My philosophy is, if you want to take it, it's yours to take. You need to make sure that you have tools to do it. All the resource materials are online, so you can judge pretty easily whether you have it. In terms of what you need, you could certainly take those courses concurrently. I think what you need to be able to differentiate and integrate. You don't need to solve partial differential equations. You need to know what F equals ma is. And that's the single most equation that we'll use in this class. And so it's up to you as to whether you take it without those prerequisites. But I will not enforce those prerequisites. Whether someone comes through from our department and enforces them for me, I have no control over. But I won't do it willingly myself. If you're nervous about it, come and talk to me whenever. I have kind of an open door policy. Not so much for solving questions for homework, which I'll pass to the TAs, but if you want to chat, I'll be happy to chat. It's kind of nice to have some contact with young people, which is the great thing about State College, of course. It gets renewed every year, even as some of us get a bit older. Grading is set up on this scale there. Mostly 25% of it is non-exam and 75% is exam. Exams are the only way to do it, so it guarantees that it's your work, which is important. There are weekly assignments. Most Thursdays there'll be a midnight deadline. You do them online, and you need to submit them for that. So I'm seeing if those are up already. Is Angel still open for me? Yeah, was Angel up? Yeah, Angel still is up. So the assignments are done online on Angel and a bunch of other things. So problem sets. So if I make myself a student, then I think I might be able to do these. And so they're the questions that you see in your syllabus, which we haven't gone through yet. And you need to work out the answers and submit them online. You get 3 attempts. I think this might be my second attempt. And I'm just doing this so you get to see the feedback. Quick, get those questions. What are they going to be right? Yeah. So you get 3 attempts to do it, and it tells you whether they're wrong. It doesn't tell you the right answers. I found out yesterday or the day before that it had been given the right answers in the first take. So to me, it doesn't matter. So this is to get you engaged, get you thinking about questions, to get you used to doing quantification in this class. Everything is really calculation. I always remember the quote from J.J. Thomson, the physicist, Lord Kelvin, Kelvin units, paraphrasing it. Now, if you can describe a process, that's all very nice, but if you can say something quantitatively about it, then you really do have something going for you. Just checking the time. And so you get 3 attempts to do this. I think that might be my third. Oh, I got one right. Quick, get that one down. Water column is greatest. And etc. So you see that. So I'm being kind of flip here. So it's a midnight cutoff. It's probably 2 o'clock actually in the morning of Friday, but do it on time. No retroactive stuff. If you choose not to come to class, fine. But just make sure that in this kind of big boy, big girl attitude is that if we're behaving like adults, you're calling me by my first name, then we treat you like adults and expect you to do these things and not come back, oh, geez, I was partying and forgot to do it. Well, that's unfortunate. So you just lose it. So basically not doing one of them, you lose 1% of your grade. So it's not terrible. And I'm usually a stickler for it. I guess you could go around me and try and persuade the TAs. They might be a bit more accommodating, but I'm not sure. So 15% on the assignments, 10% on a presentation. So we will group you into groups of 5 or 6. There are 300 students in this class, so we'll probably put you into groups of 5 so that we have 60 groups. 60 groups means 10 presentations in one period. For 3 periods in a week, that's 30 presentations. And we also put in some evening presentations. And what we want you to do is to take on a topic of fluid mechanics interest. And I'm trying to open, this is the big reader, the 50 megabyte reader that we mentioned. And so this 10% assignment is to basically develop, I won't say, actually don't look at this, I'll look at the results. So this is the idea. So what I want you to do is I want you to make a presentation with 1 slide only that has to take an interesting fluid mechanics problem and to find something strange about it that's kind of mysterious perhaps and to develop a hypothesis of why that is so. And to not only develop a hypothesis in kind of a descriptive way, but also to do it in a quantitative way. And so there are a couple of examples on here. And I guess unfortunately the hot links in this don't work. So maybe I need to do this. So this stuff exists in the native PowerPoint files, I think, on this group presentation examples. Yeah. So I'll see if these links work. Yeah, so looks like it does. It's thinking about something. Oh, that's interesting. Yeah, okay, I don't like this screen view. So, this one is a very simple idea. Let's see if this movie works. Very high tech, isn't it? It's going to work. Is it trying to play? It's trying to play. Oh, yeah.
What did it look up?
I never saw anything like
Audio on.
an enormous wall of water coming towards us.
In the early morning hours of New Year's Eve, Gene Hackman, Ernest Borgnine, Red Buttons, Carol Lindley, Roddy McDowell, Stella Stevens, Shelley Winters, Jack Albertson, Pamela Sue Martin, Arthur O'Connell, Eric Shea, and Leslie Nielsen were aboard the SS Poseidon when it was hit by a 90-foot tidal wave. My God. And capsized.
All right.
Poseidon Adventure.
That's all you get. The Poseidon Adventure. Anyone seen the Poseidon Adventure? Doesn't matter. The relevant part of that, two interesting fluid mechanics part. One, in the middle of the ocean, a tsunami doesn't look like that, by the way. Doesn't crest. We know that now. Perhaps in popular lore, but perhaps not so well whenever this was through. But you notice in the water flowing over this, could you tell that was a model? Was that a real ship? Model, right? So what is it in your senses that tells you that that's a model? So I don't know what the answer to that is, but I could hazard a thought that maybe it's because of one of these two phenomena, which are very easy to probe. One is you see a ship and you see a big glob of water which looks the size of this room. And so can water droplets get to be the size of this room? You can show very simply in stuff that we'll talk about this week that you can describe the largest kind of water droplet, rain droplet you can get should be a few millimeters in diameter. It can't be the size of this room. And so that's certainly one of the visual clues, I think, that lets you see that this is a model. I think the other one, or certainly another one, there may be others as well, is that if you take a raindrop and you drop it, and it's moving over the length of a scale model, and it drops that length in a fraction of a second, then you get that visual clue of how quickly that's moving. If you drop it from the roof of this, say 30 feet, to go the depth of a real ship, say, or even more, then it would take much longer to traverse it. And so the scaling that you get from the velocity of these droplets in this thing is another part of, I think, the visual clues that, as very smart people and very smart organisms, I guess, we're able to pick that out and to do that. And so I think that's one of the interesting deals. Is this my PowerPoint? And just to show that I have a, you'll never believe it, just to pretend that I have a sense of humor. You write this one. See if this one works. I like this. I just think it's funny.
Das hier ist mein Sektor. Das hier ist das wichtigste Gerät des Küstenwächters. Das Gerät ist das Überlebensradar.
Mayday. Hello, can you hear us? Can you hear us? Can you... Okay, over. We are sinking.
Hello? This is the German Coast Guard.
We're sinking.
What are you thinking about?
There you go. So, yeah, funny, isn't it? All right. So where are we in this? Oh, we're still talking about the syllabus. Okay. So we'll do that as presentations. It's sometime deep in this. It's like the 13th week. Last year, for the first time, some of the students in this class chose to do YouTube videos for 5 minutes also. And so 5 minutes is a few minutes for presentation and swap out. So it's really a 3-minute video. And so some of them chose to do maybe 10 or 15 or 20, maybe 15 chose to do that. And I'd imagine that might be a growing interest in the group here. And that was certainly fine last year. Midterms are in the evenings. The schedules for those are set. These are the red dots on this last third page. And they're on the evenings, sometime 6, 7 till whenever, on the evenings of September the 24th, October the 22nd, and November the 12th. So those probably won't change. They're nominally 2-hour exams, 3 questions. All the old exams are available to you with worked examples from the last 5 years. The one point I want you to take home today from anything I've said, look at those exams today. The assignments are not representative of what you'll be asked to perform. So before next time, grab those off Angel and look at them. If you understand everything on them, then fine. You don't need to come to class anymore. Just turn up for the exams and we'll be happy to give you your grade. But look at those today or this week. I'm always bemused that historically, I've said this also previously, historically the first exam is just a disaster for students. Because I don't know why. I mean, I make this statement every time. People come in there and they're just blown away by it. And it's tough when you get it's much better to come in and get a great grade on that first exam, and it sets you up for the rest of the course, and life is wonderful. And so I strongly encourage you to do that and to get everything in row to be able to perform well on that first exam. So the blue dots, blue circles are review sessions. We'll have an evening review session before each of them. Typically, the first one's really well attended. The other ones are less well attended, but so you can see the dates on those. And I won't go through what the exams are, but obviously the weighting of them is 15% of your grade for each of the midterms and 30% for the final. So that's where the grade comes. And we've done it that way because it really is the only way to guarantee that it's your work. We encourage group work in other areas, but submission of your own work. But the only way to guarantee it for exams, I think, or otherwise, is by exams. So you see that. So those are the dates that are set. We're pretty, I don't want to belabor the point. I'm not sure whether this is the place to mention it. So we've talked about assignments, we've talked about group. Yeah, perhaps it is the place to mention it. I mean, we do deal with the Penn State's academic integrity stuff. So do your own work, work in groups, but submit your own work ultimately. Certainly, the vast majority of students are absolutely dead honest, and there's a small cadre who will cheat. I think last year maybe there were 4 students who didn't make it through the class because of cheating in exams. And it ranges from, it's just copying other people's stuff basically. So we'll attempt to keep you honest. But basically, if you're copying off someone, then I will fill in the AD stuff to get you thrown out of the class. Typically, in the tribunal, that happens that they'll change that to getting a 0 for the test, and that a mark goes on your record, so that if you do it again, there's some kind of record of that. But we take it seriously because most of the students, most of the students want us to take it very seriously because most people are playing by the rules. So, as I say, last time 3 or 4 people maybe copying, and those went to tribunals and ultimately were upheld. One person came back with a 19 out of 100 for one question, and miraculously it was a 99, and with answers changed and stuff. Yeah. So don't do it. Just don't do it. I won't say any more about it other than that. That's we don't want to talk about it, but we do adhere to Penn State's academic integrity policy. So you need to be available on those evenings for those exams. And so mark the evenings. Fine. Family emergency is okay. Something going on in your family, car accident, getting to the exam, that's okay as well. Feeling terrible, doctor's letter, that's okay. You need to substantiate it. I think what's not okay is, I've got a philosophy 12 class that evening and I can't make it. Now you need to skip the class. If you're skipping my class, man, you can skip that class too. And also, I think there are also a cadre of people who are using a lab class, maybe rock and fluid properties, to skip it sequentially and to try and, I think there's for many people they're just caught in the system, but some people certainly used it to their advantage to do the exam later, because the makeup exam is always later. And when we changed it around, it certainly seemed that people were expecting certain questions and didn't get certain questions. So you need to be available on those evenings. And if you're not going to make it, then a conflict exam can be arranged, but I'll make the point, as it makes the point in here, it's a courtesy rather than a guarantee. You're not guaranteed a conflict exam, it's a courtesy that we would give it. The grades, we're getting all into this kind of mechanics of things. Take the class, enjoy the class, work hard, get a great grade on the first exam, and you're set for the rest of it. The grades are not curved. We use raw scores. For the exams are at 110%. So there's 3 questions, each 110 points, so it's out of 330. And so you could get 110% for an exam, and you get that. And I think we'll do that again. We've done that for the past couple of years. I think what it does is it advantages the serious students who are not blowing it off and who are engaged, who can get a head start and get themselves a buffer so that when it gets busy at the end of the semester, they're not under such a big pressure to perform. And the students who blow it off and don't score very well. And so I think we'll continue to do that. So the exams will be out of 110%, and you only need 100% to get 100%. So you can possibly boost your scores over that. I think last year, maybe out of a similar class size of, I think we had 280 students last year, I bet you 20 people had greater than 100% cum grades on them as they came out of the class. And of course, these scores here are the regular course divisions. So it means that everyone above 93.3 all the way up to 110% gets an A. And that's why the weighting of the A's that you just saw on the stats was relatively high. It's like 20%, which is fine by me. It's fine by me if every single person in this class, by the way, gets an A. It's based on absolute performance. It's not a curve. It's not that some of you are going to do better than others. It's defining exactly where the, what kind of problems you should be able to solve based on what we've talked about in class, and to hold you basically to that. And I think the rationale for that is that ultimately when you go out as scientists, certainly as engineers, licensed engineers ultimately with the public good in hand, you have to be able to do these rational calculations to be able to figure out that things are safe for the public good. So, notwithstanding things like Deepwater Horizon and other things going on where clearly unfortunate errors were made, but you need to be able to have the tools to be able to try and avoid those things. How are we doing for time? I guess I can't see. 10 minutes to go. So I won't belabor the points of what we need to do. We'll go through, maybe it's worthwhile just explaining what the syllabus looks like. So we have, what do we have? We have 14 topics kind of broken up with 14 weeks. The 1 week that isn't in there, I guess, is this week here for presentations, which is in the 13th week, as I say. Each topic has me prattling on about it at each of the 3 lectures we'll typically have in that week. And so we're on topic 1 now, doing the first part. Homework 1 will be live, well, I think it is live now, but will be due a week Thursday, not this Thursday, but I think it's September the 4th. The 1st is Monday, right? Tuesday, Wednesday. Yeah, so September the 4th at midnight. And you see the materials there. We'll have the stuff in class because that's where we are now. But this is something I'm going to try. I'm going to try doing stuff online, broadcasting it in these blacked out portions, just because I'm curious what it is, and just because I'd like to try it that way. Certainly, you can get it all on Connect, as we're being broadcast on Connect right now. And so that's my plan. And also, the other thing I wanted to do is, certainly we have the stuff recorded from last year, and so you're welcome to come to class prepared by looking at the stuff from last year that we talked about. It's not going to be so different from what we will talk about in class, and that might be a good way to prepare for these things. And then when we get the new recorded material, I'll move that to an archive, and you'll have the stuff actually recorded in class. So that's my plan, is that we'll certainly meet for the next 2 weeks. I'm still trying to feel out exactly how we're going to do this stuff online. To broadcast it and to record it, it's no different from me standing here and doing it. I guess I might be interested in doing it in my office or something, or perhaps I'll come here anyway and do it. So the people who want to come here can do it. And in some cases, rather than make new notes, which are almost the same as the others, maybe I'll do some kind of experiment and look at something like these ripples in the grass from erosion that you'll see as you go outside of Sparks in the mall on this side. And also it's the same kind of features you see in the on the mulch as you go out on the other side. And so you'll see the topics we go through. So properties of fluids, fluid statics and pressures at a point. So pressures at a point means that when you go up in the atmosphere, when you fly at 35,000 feet, the pressure is less than at the bottom. Why is that? We can calculate that pretty straightforwardly. The plane you're flying in is designed so it doesn't unzip at that height. So fluid pressures on structures, both from the fluid pressure inside, which is typically larger than the fluid pressure acting outside. It's important that we understand those pressures so that fuselages don't unzip. We'll spend a couple of weeks talking about Bernoulli, so pressure head, velocity head, and elevation head being equivalent at different locations. You've certainly seen that in your background in the past. And we'll look at more sophisticated methods of doing that in terms of using control volumes for conservation of mass, for conservation of momentum, which is really Bernoulli's principle, just shown in perhaps a more convenient way and perhaps more versatile and sophisticated way, I guess is the word I was looking for. We'll look at conservation of energy, to look at how much energy you can get out of a wind turbine, or out of a hydroelectric scheme, for instance, and other engines. We won't really move into the territory of thermo, which some of you might be taking also this semester, 301. We'll talk about the heavily developed area of experimentation in fluid mechanics, where we use similitude between properties and dimensionless numbers to be able to say something very useful about model planes in wind tunnels that can represent real planes flying in the atmosphere, for instance. We'll talk about viscous flow inside pipes, for those of you interested in pipelines, ductwork in buildings, well bores, in the subsurface, roadways in mines, etc. And so they're all reduced to some flow inside some contour. We'll talk about external flows, flows around windmill blades, around sails, and around water towers, anything around cars, drag resistance, around falling parachutists, for instance, as well, I guess, the same thing. And we'll then talk about open channel flows. So flows with a free surface, like surfing West Virginia in a whitewater kayak or doing other things. Academic conduct we already talked about. A couple of statements relevant there. Yeah, don't cheat. I mean, don't cheat. But the other one is, I think Penn State's policy encourages you to come to class. Of course, I'm trying to take some of this online, and so I encourage you not to come to class then. To me, come to class, not come to class. You know, once this class gets going, last year we had 60 people out of 300 coming to class regularly, perhaps even less. That was their choice. I did try and assay whether, you know, the people coming to class were the ones who are the high performers. It didn't seem to be a clear-cut deal. Maybe slightly, but it seemed that the people coming to class were across the spectrum. Some absolutely understood it all and were just here for entertainment. I'm not sure how much they got, but they're here. And there are also some people here who really didn't get it and were just hoping, you know, are you going to send the class list around? Can we sign our names for extra credit kind of deal? And so there was that spectrum of people in that class. But so attendance is optional, and but I encourage you to come to class anyway. Where are you going? We're not finished yet, man. It's only 8:44. I've got 6 more minutes to talk at you. Any questions? And then I've got some more stuff to say after that, by the way. No questions? So I think I've said all the things I wanted to say in terms of organization of this. Yeah, we've talked about the assignments. The other resources is a lovely equation sheet. There's also equations at the end of each chapter, I think, in your book, which kind of mimics this. I think my equation sheet's better. Typically, before the exams, I'll put together a crib sheet. And the crib sheet is basically, we'll take the material that we've covered in my 400-page compendium that we'll use for these overheads. We'll take the material from that, and I'll try and cull it down. So at least I realize that you have, 6 other classes that you're doing. This should be the only class you're excited about, but it might not be the only class you're excited about. And so I realized that to try and throw you a bone, that we'll try and make things at least manageable for you by at least cutting down some of the material that you perhaps have to review to make this. But my passing point in this is that the same point we entered into here with, and that is that fluids are around us. Literally and figuratively, they're all around us. Air is a fluid, it's a gas rather than a liquid, but it's a fluid. That's the general term. And the fluids are engaged in all significant processes. So Napa Valley earthquake yesterday, magnitude 6.0. It's inland, no tsunamis, but certainly since 2004, and then March, so Boxing Day 2004, and March the 11th, 2011 in Japan. Indonesian earthquake and Tohoku earthquake. Big issues related to tsunamis occurring from earthquakes, which we don't say. Hurricane season, which is just coming. Fluid mechanics again. And the way the Earth works in terms of creeping flow in a core is all related to fluid mechanics. The rate at which glaciers creep is ice at some level can be defined as a fluid. It creeps very, very slowly compared to even treacle or molasses, but it's moving nonetheless. It's a creeping solid. And volcanic eruptions, you're definitely too young for this. May the 18th, 1980, Mount St. Helens, the only big eruption that's happened in the conterminous United States. Many of you are engineers, and so many of the systems that we use, from flying airplanes, from not grouting wells well enough around boreholes in the Gulf of Mexico, the whole Deepwater Horizon debacle, getting gas from Gulf to door. There's a huge network of gas pipelines in the U.S. The Tacoma Narrows Bridge, which pulled itself apart, is another fluid mechanics problem. Wave energy, wind energy, figuring out how fast you're flying in a plane from a really rudimentary piece of equipment, the pitot tube. By the way, you know, the downing of the Air France plane that flew from Rio to Paris that didn't make it was because a pitot tube, tiny little piece of equipment that measures the airspeed, froze up, apparently, iced up, and you can't tell how fast you're going anymore. And they made some decisions based on that, and they weren't good decisions. Contaminant hydrology, DNAPLs, organic fluids in groundwater, and geothermal systems. Gas fracking is a fluid dynamics problem once you get the stuff into the wellbore. And the final slide is in recreation. Speed suits in the Olympics to go faster. I guess they don't have those anymore since the Australia Games when the torpedo was using them. But with little things on them so they aerate and they reduce drag by some design mechanism. The keels of the America's Cup boats, when Dennis Conner was doing it, maybe 15 years ago, when all of a sudden the America's Cup wasn't American anymore because either New Zealand or Australia won it. And they put a shroud around these fins on the keel so you couldn't see what the secret thing was, but they made the boats go faster. Sails and rigid sails on sailboats. You know, why is a golf ball dimpled? Why does a baseball curve? What's surfing West Virginia all about? They're all fluid mechanics problems, including, of course, boarding and why you spin a football. So all related to fluid mechanics. So, fluids are all around us. We're going to have great fun in this class. Hope you'll be here on Wednesday. We have a question. And we're done.